IVM.
The grocer, the butcher, the taxi man, all seem delighted to share in our pleasure. The Nobel Prize is an honor unique in the world in having found its way into the hearts and minds of simple people everywhere. It casts a light of peace and reason upon us all, and for that I'm especially grateful.
Those are the words of George Wald from his speech at the Nobel Banquet from 1967. He shared the Nobel Prize for Physiology or Medicine for his work on vitamin A and how it is an important component of rhodopsin which makes our retinas work. More than a century after Alfred Nobel bequeathed his wealth to establish 5 prizes across the sciences and other fields, the Nobel Prize remains the greatest accolade a scientist can receive for their work. Professor Gautam Menon from Ashoka University and the Institute of Mathematical Sciences, Chennai, joins me on this episode of the Pragati Podcast to talk about the Nobel Prize and its role in science and how it shapes science in important ways. Welcome to the Pragati Podcast, a weekly talk show on public policy, economics, and international relations. We take a step back from noisy political debates and dive into rich conversations on India and the world. I am your host, Pavan Srinath. We'll start this episode's conversation after a short break.
Hello, everybody. Welcome to another awesome week on the IVM Podcast Network. If you're not following us on social media, please do. We're IVM Podcast on Twitter, Facebook, and Instagram. It's been a really great week on the network. Let me make a couple of recommendations to you guys. Agla Station Adulthood, they have an extraordinary episode on relationships. Ritasha and Ayushi, as always, do a bang-up job. I think you'll really enjoy that conversation. Check out Edges and Sledges, where DJ Ashwin and Varun have been talking to fans from different IPL teams on every episode. It's a really interesting project they've taken on during the course of the IPL. And as it comes to a conclusion, I'm sure you'll love to hear their thoughts on the tournament as a whole. I want to mention Uncle Please Sit. They had a really great episode which dove into why is pollution so bad. And I think that given the circumstances we're dealing with right now, it makes a ton of sense to listen to that. Cyrus had a really great week on his show as well. On the Monday episode, he spoke to Raj and DK about all kinds of stuff. He was in one of their early movies. Definitely a fun conversation. Do check that out. And finally, let me talk to you about the Wire Talks with Siddharth Bhatia. We're very excited about this show. On the first episode, Jairam Ramesh is there having a conversation with Siddharth Bhatia about the legacy of Indira Gandhi. I think you will really get something out of this. Do give it a listen. And with that, let me get you back to your show.
Hi, I'm Pavan Srinath and welcome to the Pragati Podcast. I'm joined today by the wonderful Gautam Menon, Professor of Physics and Biology at Ashoka University, as well as a professor at the Institute for Mathematical Sciences in Chennai. Gautam, it's a pleasure to have you on the show.
Pleasure to be here.
And Gautam, I know that you've been leading some fantastic epidemiological modeling work that India badly needs around COVID-19. You've been one of the initiators of the ISRC, the Indian Scientists' Response to COVID-19. And you've also been giving extensive talks, live on YouTube, on podcasts and elsewhere on, how India as a country and our states are managing the pandemic. So today, as much as I would love to talk to you about COVID and I have endless questions, thought we'll take a step back from all of that and talk about the annual Grand Prix of Science, the Nobel Prizes. And we had them happen in October. And I'd love to go deeper into how the Nobel ends up shaping science and the life of scientists and researchers. And I was hoping that, you can shed perspectives as a practicing scientist on how you've seen this happen around you and elsewhere as well.
Sure, happy to do that.
So, Gautam, in October, we saw the 2020 prizes and, as always, they go to exceptional scholars across fields. And for the purposes of our discussion today, I want to sort of limit this to the Nobel Prizes on physics, chemistry, and physiology or medicine, right? Because the Nobel for economics, the Peace Prize, and so on, there might be different dynamics there. So I want to get at the heart of what these prizes mean. So would it be fair to say that the Nobel has an outsized role in either being an inspiration for scientists, an aspirational goal, a motivator, and an anchor for practicing scientists compared to, other prizes and other achievements?
I certainly think so. I'm sort of going back to how I thought about this when I was young and growing up and wanted to become a scientist. And I certainly think that the idea that you could have something like a Nobel Prize that rewarded a career in science or in a very important achievement that everyone around the world could see and respect you for, I think was very important. So personally, yes, this whole thought of a Nobel Prize as a sort of epitome, the peak of achievement was very important. I think now it's been a little diluted because of the appearance of many other awards. For example, the Millennium Prize, which is much advertised. It's largely US-centered, but it has a Hollywood aspect to it as well, with Hollywood actors and actresses also being part of it. And the monetary value is probably larger than that of the Nobel. So I think when I was growing up, Nobel was really, as you said, the apex of anything that a scientist could aspire to. My examples are going to be largely from physics and some from biology, maybe a little less chemistry, because these are the fields that I know more about. So to, again, describe what it was when I was growing up, certain names like Einstein, Madame Curie, Raman for sure, the names that I listened to when I first thought of becoming a scientist. Watson and Crick, certainly Richard Feynman, because of his communication, his book was very much an important figure in part of it. I read a lot of popular science, a lot of quantum mechanics, all of it sounded somewhat mysterious, a lot of chemistry, really. Although in chemistry, the sort of big names in chemistry, apart from Madame Curie, didn't figure so much. So I don't think I heard about Linus Pauling until quite a time later. And I think for a young person, the idea of knowing something for the first time, being the first to know something, the first to find something, really is quite significant. And to be held in regard by larger society is also something that a young person thinks is going to be very important. And then finally, I see this a lot in young graduate students who are just starting off their PhDs, and the isolated genius, the iconoclast who sort of finally, the whole world accepts his genius, etc. There's a sort of cinematic element to this, which I think is also important to some fraction of graduate students. They enter science because of it's the whole sort of the drama of that achievement is something that strikes them. Of course, there's a sort of aphorism that I have. It says that for a young Indian, whether someone is famous or not depends upon whether they're the answer to a quiz question. So it's sort of, who won the Nobel Prize in such and such a year? What did they get it for, etc. It's a canonical way in which you would post that. Of course, as I grew older, there were many more names that entered this description of other Nobel Prize scientists and people I could look after. They could then identify what it is that they did. So certainly in the Indian names, C.V. Raman, Abdul Salam a little later, S. Chandrasekhar, again, very important when I was an undergraduate student learning about physics. That was my sort of experience of first seeing a Nobel laureate for the first time. Understanding a little bit more than just a purely popular description of what it is that they did. So it's sort of, there's a long detour from your question, but certainly it's true that the idea of the Nobel Prize is, I think, very important still to young people for all of the reasons that I described.
Much more so than various other prizes, right? There are many achievements that they'll be very important for a scientist's career. But from this inspiration point of view, especially when you're starting off, and this is the moonshot, right? This is what you hope you can achieve one day through decades of toil.
Yes. And I think that's because it's a very international prize. And I think that there are lots of national level prizes that, the common person in the street might not know, might not hear about, or even things like the Wolf Prize, which is in a sense an international prize. It's considered a precursor to the Nobel, but ordinary people don't know about it. But I think that there is a sense in which the Nobel Prize is one thing that everyone, wherever they are, Japan, China, Taiwan, South America, etc., or India, knows about. So there is a certain cachet to it that's hard to replicate in any other award.
So much so that in other fields, like the Fields Medal in mathematics, is referred to as the Nobel for math, right? Very colloquially.
Exactly.
So there's that kind of an anchoring effect that the Nobel has, even in fields
Although I must point out that the bar for the fields is much higher than the bar for the Nobel. Because you have to be below the age of 40 to qualify for a Fields Medal.
Right.
And so the age constraint is very, very rigid. It's not a lifetime achievement award. It's for work done before the age of 40.
It's obvious that we need to see diversity in leaders and achievers, and that makes a huge difference in, inspiring people to do various things. And so therefore, in the Nobel, it'll play an even more outsized role, right? When somebody who's not a white man wins a Nobel, right? I mean, like, I think 20 out of 600 plus Nobel winners have been women till date, if I'm getting my statistics right. Largely people are European or American in origin. Increasingly, there have been a lot of Japanese winners and a handful of Indians, by and large recognized for their work done outside India and for careers and for science done outside India, right? So clearly this, every time, like this year, 2 women winning the chemistry Nobel makes an outstanding and an outsized impact on driving the careers of future scientists.
Yes, you're right about that. And I guess this is something that I had not realized until I grew older, how much the importance of having an appropriate role model, the importance for women to see another woman at that level of success, the importance of someone to see someone brown-skinned or black, to be very successful in an area that they're part of, that they participate in, and to understand that there is no barrier to them to achieve the same sort of success. So, I mean, the lovely pictures of Abdul Salam, resplendent in a turban, and his Nobel lecture refers to the traditions of the Arabs and the Indian. He even mentions, in fact, I just looked at this as a preparation to this particular podcast. He mentions Maharaja Jai Singh's work on astronomy as a precursor to much of the work that happened later in European science. Chandrasekhar is another example. Again, very noticeably Indian, always dressed somewhat formally in Western style. But again, deep Indian roots, relatives who were Indian. He would come back to India once a year and would be part of the scientific establishment in India. And he would give talks at the Indian Institute of Astrophysics in Bangalore, where I would listen to him multiple times. Hargobind Khurana, another remarkable Indian who did all his work really in the West. But again, very recognizably Indian. There is a scholarship in his name that is set up for Indian students to work in American laboratories. And of course, Venki Ramakrishnan from a much more recent time. Again, he left India fairly late. He left after a bachelor's degree and has, again, many deep connections to India. Parents are here. So, and he is, when he comes back, he's sort of feted and recognized and on multiple committees and on TV, etc. But again, that sort of idea that you see someone who looks like you,
right,
reach that pinnacle of achievement, I think really significant. And I had not realized this earlier. I realize it increasingly now, the importance of having such. The counter to that, of course, is the fact that we try and convince ourselves that science is an international enterprise. It doesn't matter who you are. Maybe Brazilian or Ecuadorian or, from South Africa or from Italy. No color matters, no background matters, there's things. And to an extent, when you work with scientists, you realize that a large part of that is true. And there is some part that is not true, and it depends very much on the luck that you had and the collaborators that you have, the sort of people that there is no universal. I don't think this is sort of universally accepted as the underlying fabric of science, even though we may like to have it like that. So, there are these two things that compete against each other. But I think the overriding part is the part that you mentioned. One does need role models. And the Dudna Chopin Nobel Prize is a nice example of people of 2 young women scientists who did outstanding work and were recognized in fairly short order after they did that.
We also see various levels of internalization of this, right? I remember my undergrad institute director, one of his favorite anecdotes was that when he applied for a job as a chemical engineering professor, his good friend who also did his PhD sort of with him also applied, and, he had much better publications, much better everything, except that, one applied from a return address from the US and the other from Mylapore in Chennai. And just that, he says, made a difference. So we see a lot of that internalization and that credentialization of where you've done what. And unfortunately, rather than have science speak for itself, the practice of science still involves credentials.
Yes, exactly. People finally have to decide, and your
identity matters.
Exactly.
So here then, if I want to take a step away from the Nobel, and how would you look at various kinds of awards that you might receive in your career as a scientist and their role in your career, right? I mean, like, for example, it could be a named fellowship while you're doing your PhD. It might be a prestigious postdoctoral fellowship. It might be an award you might win as a young scientist, trying for tenure track, assistant professor. how do these awards and their importance in the scientific career compare to, say, publishing papers in top journals, gathering a lot of citations and so on? How have you seen this play out?
So we've seen it play out as not a very positive way. I think we, especially in India, we tend to put more emphasis on the awards themselves. And then you have people sort of in a cycle of trying to get every award there is. They ask to be nominated. They ask to be put on the short list for things. There is some amount of canvassing. And the job of the people who have to decide is not an enviable job, because it's sort of decisions that you have to make are difficult decisions. So I guess I'll tell you what my main problem with this is. It's not so much the recognition of the work that is done, although we have to remember that if someone got the award, they probably certainly deserved it. But that doesn't mean that those who didn't get it didn't deserve it either. And often these are very, very difficult distinctions to make. How do you distinguish between someone who is well funded, has a well set up laboratory, or inheriting someone else's well set up laboratory, and therefore, and versus someone else in a much more difficult situation, working in a smaller university with limited funding, yet accomplishing some things? To what extent do you weight the level of deprivation against what they achieved? That's certainly something that is to be important. To what level do you encourage science and scientists who come from a university system vis-a-vis scientists who come from a system of relatively better funded institutions, such as the Indian Institute of Science, or something like some similar example? These are all hard decisions to make. And my issue is more that an award is treated as a qualification for things that are not related to the award. You give X an award, and then they suddenly become an authority on lots of things unrelated to the work that X did, who X was awarded. They become sort of on lists of administrators or directors or something, etc. And partly that is signaling. You want to signal that, look, we have a director who has all of these awards that are swanky and impressive, etc. And that sort of signals our eminence as an institution. But these are not the same things. Administrative expertise and administrative ability don't correlate at all with scientific ability. And that's where I think that the disconnect begins, that we attribute to awards more than they should be used for. They're an acknowledgement of a certain level of quality of work, a certain individuality, a certain scientific excellence. But they're not a guarantee of anything else. That's I think, the point where we should be clear about what they do. So they do distort. They certainly do distort. And at some point, I'm not very sure what the trade-off ought to be. There's a nice example from my own personal hero. This is called Kenneth Wilson, who, it's a long series of interviews to the American Physical Society before he died. He made the point that the amount of money given to the Nobel, he was a Nobel Prize winner, in a sense distorts the nature of the award. He said getting a Nobel should be no different from becoming a member of the US National Academy of Sciences. It should not be held in much higher regard than that. And he worried a bit that the large amount of money associated with the Nobel Prize was distorting, in the sense that people thought that was an award to get as opposed to something else that reflected a more genuine regard of the community for the work that you did.
But over time, the monetary value of the Nobel has perhaps reduced, right? I mean, right, if you look at research funding that might be received by people, especially in the experimental sciences, they can be immense. The payouts from patents and from other things might be more. And there are other awards like, the MacArthur Genius Grant and so on, which is like, $1 million, untied, do what you want, spend it on yourself if you want, spend it on research. So perhaps the monetary value of the Nobel has come down.
So this was an interview from about 30 years ago. So I think since then the situation isn't what it used to be.
Right.
But I think the more general point is that I think he said that you tend to put the Nobel on a pedestal.
Right.
And maybe you shouldn't do that. It should be thought of as scientific acknowledgement or an honor that's not too far behind other sort of reasonable honors that a scientist might be expected to get if they're exceptional enough.
And one of the things that's often talked about with the Nobel Prizes is when the Nobel-worthy work was done and when the awards are awarded, right? And typically the gap can be immense. I mean, it could be work done by a scientist in their 30s or maybe early 40s, and they might receive it after retirement from science, or when the emeritus profs in various places. So how do you see this? There are, of course, salient exceptions. Charpentier and Doudna are two great exceptions where their work on CRISPR and Cas9 was done less than a decade ago, some of their Nobel winning papers, and they got recognition when they were still in their 50s, when they have a long scientific career ahead of them. So can you tell us a little bit about how you've seen this play out?
I think there are examples on both. I mean, if you go before Ashoka, there is Brian Josephson, who did his work when he was, Josephson effect, when he was a PhD student. He was 22 years old. And maybe even a master's student at that time. And he was awarded around 11 years later. So he was 33 when he got his Nobel Prize. Again, wow. So that's a really short period in terms of how one thinks of these things. Walter Kohn, really influential. Both, whether you call him a physicist or a chemist is a matter of distinction, but an extremely influential scientist and probably the most influential of the last sort of 50 years in his particular field. He got it 35, 40 years after his work. This is really important work. And, that was again a Nobel Prize that was almost foregone. The only question was, why didn't they give it to him earlier? Why did they have to wait for so long? Gross Pulitzer and Wilczek, who discovered asymptotic freedom in QCD. That was again a Nobel Prize that everyone felt they should get, but I think was delayed probably by about 30 odd years between their initial work in the early 70s to when they were awarded it in the early 2000s. So I don't know. I don't think there is Alexei Abrikosov, again, did his work as a PhD student in the mid-50s and was awarded around the 2000s. Again, a big gap there. I don't know if there is any universal sort of rule about this. I think now the committee is a little more inclined to give it to people who are younger rather than for people who come from way back. But that's just a guess. I mean, that's just sort of guess based on this year. And there's always some backlog to worry about. There's always newer things that are happening. So how to strike that fine balance isn't always obvious.
So Gautam, how does one, both in theory and then in practice, judge then if somebody's contributions are Nobel worthy? I mean, is it at all possible to be objective about this? I mean, we can go down the whole route of, science metrics in terms of citations and impact and, we can get overly quantitative if we want to. But at the heart, are these fundamentally subjective calls made by a set of people? And is that still valid?
I'd go back to that statement that, those who get it deserve it. That doesn't mean that those who didn't get it didn't deserve it. And it's a very, very fine line there. I mean, the examples of the women who didn't get it. So let's take Vera Rubin, again, extremely famous American astronomer. We can look at Lisa Meitner, the German nuclear physicist who didn't get it. She was nominated many, many, many times, but she didn't get it. Obviously, she was certainly worthy of the same prize that many of her male compatriots got at the same time. Rosalind Franklin, a somewhat complicated story, and she died before the award was made to Watson, Crick, and Wilson. And this is for the discovery of the structure of DNA. And Madame Wu, C.S. Wu, who discovered that parity was not conserved in an experiment, a proposal that had been made some years ago by two Chinese-American theoretical physicists, Yang and Li. So Yang and Li got the Nobel Prize, but C.S. Wu didn't get it, even though hers was a pivotal experiment that actually demonstrated that what they said was correct. So these are all, I don't think in today, had the identical situation panned out, I don't think the Nobel Prize Committee would have got away with not giving it to C.S. Wu. And I think that's some indication of the fact that we have moved forward since then, that we are willing to acknowledge the mistakes that were made in the past. So I just use these as examples because they're particularly interesting examples of women who, at this moment, at the same Nobel Prize Committee had to make that call. I think they would almost definitely have come to them. And that's certainly one thing to keep in mind. There will always be people who deserved it and who will not get it. And again, that is something that we have to keep in mind. And I think my own favorite Indian example would be G.N. Ramchandran, who was an outstanding biophysicist who worked both in Madras University and then later at the Institute of Science, whose contributions to understanding the structure of collagen. Collagen is the most plentiful protein molecule present in our body. So the structure of collagen was something that G.N. Ramchandran worked out with his colleagues. And there's something called the Ramchandran plot, the 5-side plot, which is a staple of books on biochemistry. And it's referred to now, it's a sort of universal term that's used in any paper that deals with the structure of
and it's one of the first things you learn in the fundamentals of biochemistry.
In the fundamentals of biochemistry. So these are remarkable achievements done by a person in a university far, far away from the centers of where the science was really active. And he constructed a group around him called the Madras Group, which was world famous. And this is an extremely rare and remarkable achievement for which he should certainly have been acknowledged. And that, I think, was probably the closest that an Indian living in India and working in India has ever come to the Nobel Prize. So as I said, there will be omissions, there have been omissions. There are lots of people. Finally, the scientific enterprise between the 1950s and today has burgeoned by possibly an order of magnitude in terms of the number of people working. And certainly in terms of the number of new discoveries that are being made, almost on a weekly or a monthly basis. So as long as you keep the number of Nobel Prizes fixed, but the community that sort of hankers for it is getting larger and larger, there will be people who obviously will have deserved it, but who will not get it.
Right. I mean, this is perhaps an odd example. It took me a while to understand this properly. I think the 2014 Physics Nobel went to people who were instrumental in getting blue LED to work, right? Or inventing or discovering how to make blue LED happen. And very instinctively, my thing was, is there a Nobel for the red or the green LED? And then, it took me far more reading to sort of understand that the blue LED was a big scientific challenge. There was a lot that went into it. It was hard. And because it was difficult and because it was also impactful that, people finally won the Nobel for that. So it seemed rather arbitrary sometimes. I guess it can from the outside. But at least among peers and within the community, if there's recognition, then clearly there is merit.
Absolutely.
So clearly there are many people who get left out, right? But one of the things I see is that if you look at science from, say, 100 years ago and science from now, science is far more fundamentally a collaborative process today, right? I mean, you look at any papers, you look at papers by, Nobel winners this year. It's not like they were the sole authors on their paper, right? 100 years ago, or perhaps even today in theoretical physics and in a few fields, one individual who's working out certain things and putting them out, it's possible for one person to be the engine of, innovation and scientific discovery. But otherwise, it's always a collaborative effort. So does an individual prize at some level even make sense anymore? If, there's a PhD student, a postdoc, a few people helping them out, and then, this principal investigator, sometimes multiple, who are there on work that potentially is Nobel worthy.
That's true. In a sense, the Nobel Prize Committee is bound to carry out the instructions that Nobel left in his will. So they don't have much freedom in that particular area. I don't know whether the Nobel Prize in physics can be awarded to a group, because certainly the Nobel Peace Prize, which I think is probably not one of the Nobel's original prizes, has been awarded to groups, for example, the World Health Organization or the Red Cross or institutions as a whole. And so that's certainly something that could be done to sort of reorient it so that you award it to a group of people, a collaboration, an institution, as such, rather than the individual who heads it at that particular time. And you're completely correct. The nature in which science is done is much more in large groups. The number of people on a typical paper in science or nature and biology or whichever area, or even radio astronomy, is usually a very large number. There are many people who've contributed to that particular area. And it becomes hard to single one person out as being the linchpin who is completely responsible for this from beginning to end. The crucial ideas could have come from any number of people within that collaboration, the little bits that make something work or not work. So this is something we'll have to think about going forward. As I said, I don't know if the Nobel Committee has much leeway to move away from Nobel's initial conceptualization, which he wrote about in his will. But this certainly is true that science is changing at a fundamental level in the way science is done.
But how have you seen this, at least from anecdotes that you're aware of? Are there more PhD level work or postdoctoral level work that's been winning Nobels recently, or is that all from much further in the past? Because that's also one indicator, right? Like, because today you might be, the first author on a series of papers, but, it might be the professor who you work under who might get this kind of credit. Whereas, you will get your credit as well. But that becomes a split even within a paper, right? And different fields have different conceptions of it too. Like for the first time when I learned about how economics and political science and social science papers work, they want single author papers, or, the first author matters most. Whereas in science, there's this convention that, the first author is a person who's led the work, but, the last author is the one who's sort of overseen everything, right? So how do you square this?
So I can't think of too many examples in the recent past where it's been the graduate student who has done who is credited later for the work that the advisor is acknowledged for. One old example is the example of Anthony Hewish and his student Jocelyn Bell. So Anthony Hewish is an astronomer who won the Nobel Prize, Martin Wright, for the discovery of pulsars. But what was the crucial part of the discovery was actually his graduate student's work, Jocelyn Bell. Jocelyn Bell found this remarkable structure in the measurements that she was recording. Took it to him, he didn't believe it. They spent about a year searching for all possible other alternatives. And finally, as it turned out, he was given the Nobel Prize and she was not. And this has been an issue that has sort of festered in the larger community of astronomers and scientists about, here's another example of a woman scientist not getting adequate credit for something she did that was absolutely crucial. Had she not noticed this, had she not brought this to his attention, had she not done the hard work required to isolate, to show that the signal did not come from something man-made, but was truly a signal that was coming in from outside, and look at the properties of that, this discovery would not have materialized at all. Again, I like to think that today we would handle it more differently than we did then. I'm not sure that that's true, but that is certainly one example of where the student who really contributed in a very fundamental sense to that discovery was not credited with the Nobel Prize. And of course, her fame has probably exceeded that by now that Nobel Prize could actually have given her, because people see the backstory and they see what she did. And of course, she went on to many remarkable things after that.
But there are also some structural problems there, right? Like, for example, I'm looking at how Peter Higgs and Englert, I think, who won the Nobel for their work on the Higgs boson and so on. But you needed the Large Hadron Collider and the experimental work that was coming out of it to sort of validate the theoretical work, right? And the LHC is perhaps the best example of a mega science project, right? Which is not just now one lab of people collaborating or 10 labs. This is, an institution, thousands of people working across the world, poring over voluminous data that comes out of this LHC and doing all that experimental work. And some of these papers will also have 50 authors, 100 authors, sometimes more. Sure. And then you have these, this important theoretical work that is done by individuals, perhaps quite a bit, decades earlier, which certainly deserves merit and, awards. And then you have this sort of mega science over here where even if you want to give an award, you don't know who to give it to, right? So clearly there are some people with advantages when they're walking into this.
Yeah, I know. But in that case, it's a little bit special because that they made this prediction that the fact that there should be a Higgs particle and an approximate location of what its mass ought to be, which is later refined. It's true that the sort of final part of that, the final development of the theory, required the identification of this particular particle, although pretty much people were sure that it was somewhere there, but it was a remarkable feat of CERN to actually identify it in more or less the location where it was expected to be. But the reason they were looking there was because of the prediction of the Higgs particle in that particular mass range. So there, I think it was probably right for them to get it. And, that is one example where an important prediction was made much, much in advance of our ability to even search in that particular region for a new particle. And that is, it turned out to be, in a sense, very boring from the point of view of particle physics. It had all the properties that you expected it to have, and there were no surprises over there at all. But that's, in a sense, in the fact that you could just write down these equations on a piece of paper and predict the existence of a particle like that could later, 40, 50 years later, be discovered. I think it's something that is really quite extraordinary. Even this is it's a more general scientific question. Our ability to do that is unusual. And it should give us some respect for the fact that we know so much about science. We know so much about how the universe actually functions at the level of being able to predict things that only 50 years later, someone can actually do an experiment to check.
Absolutely. I'm just thinking that, whether intuitive or counterintuitive results that come out of future mega science projects, and there are many that are there now that are going on in physics, in medicine, in chemistry, and so on. I have no idea who might end up, winning a Nobel or not winning a Nobel. And maybe it shouldn't matter beyond a point. But unfortunately, it does right now, in all our minds. So, Gautam, let's take a quick break and we'll come back. And I want to talk a little more about, the annual cycles of gossip that happen, short lists and long lists around the Nobel,
Yes.
and how it could also shape a scientist's work as such.
Sure.
Before we break, dear listeners, don't forget to listen to this episode on the IVM Podcast Android app, the Adori iOS app, or on your mobile or desktop browsers to get the rich new experience. I would also like to thank the Takshashila Institution and IPSMF, the Independent Public Spirited Media Foundation, for making the Pragati Podcast possible.
नमस्ते, मैं हूँ सौरभ चंद्रा
और मैं प्रणय कुटस्थाने।
जब महफिल खत्म होते होते दरवाजे के बाहर पुलिया के ऊपर हम दुनिया भर की जटिल समस्याओं को सॉल्व करने में लग जाते हैं तो हो जाती है पुलियाबाजी।
अब आजकल के अपार्टमेंट वालों ने तो कभी पुलिया देखी नहीं होगी, पर आप फीलिंग तो समझ ही सकते हैं।
तो आइए शामिल हो जाइए हमारी पुलियाबाजी में, जहाँ प्रणय और मैं एक से एक इंटरेस्टिंग टॉपिक्स की तह तक जाएंगे।
आर्टिफिशियल इंटेलिजेंस, बिटकॉइन, पाकिस्तान, मेडिकल एजुकेशन, करेंसी क्राइसिस, कभी हम दोनों के साथ और अक्सर स्पेशल एक्सपर्ट गेस्ट की कंपनी में।
सुनिए हमें IVM की वेबसाइट, ऐप या अपने फेवरेट पॉडकास्टिंग प्लेटफॉर्म पर हर दूसरे हफ्ते।
Hi, and welcome back to the Pragati Podcast. I'm here with Gautam Menon, and we're talking about the Nobel pursuit of science, right? Specifically, the pursuit of the Nobel Prize in science. So, Gautam, I've been following your writing and things on Facebook as well. And, every year when the Nobel happens, there's a lot of gossip and discussion and, lively, spirited discussion on who might win the Nobel. And clearly there's a whole process of nomination, long list, a short list, and, finally a winner perhaps. So how do you see this play out? Is there good gossip or good information that's available before the prize is actually announced? What's known in the community?
There's often very good discussion. I enjoy reading it. I look at a whole bunch of blogs. There's a blog called Nanoscale Views that Kenneth Wilson from Rice University comments every year on who he thinks might be potential Nobel Prize winners. Ashutosh Joglekar is another sort of science communicator, science writer who I follow, who also typically features, much of that is around the chemistry and the medicine Nobel Prizes. And all of the Clarivate Analytics, the Thomson Reuters, all of these people produce lists based on citations of who they think, they call citation laureates or something. And their argument is that people who are cited or feel that are cited very much maybe feel that are favored by the Nobel Prize committee. And often they turn out to be wrong. In fact, I think they've been consistently quite wrong over the past several years. So there's not much sense to doing that. But you get a sense for what are the things that practicing scientists or people who think about this. And of course, on being blogs, there are lots of replies saying, look, you should have thought about this. You left that out. And you get this larger picture of what is it that people consider to be significant in their own field, in the field that they work in, or in the field that they keep track of. And saying that, look, had it not been for this flash of insight, this new technique, this new way of doing something else a million times faster than it was done earlier, we would not be able to do any of what we're doing right now. And it's these pivotal little sort of steps that I think are very important. And as I said, I like to look at this discussion. It strikes me that it's often very wrong. And the Nobel Prize Committee often manages to surprise people. I think my own predictions have usually been wrong, but in a few cases they've been right. I think I predicted Abrikosov's Nobel Prize for the discovery of type 2 superconductivity before he got it. I said it would be really nice if he would get that. And the quasi-crystal Nobel Prize, again, is somewhat unusual Nobel Prize for this new sort of state of matter that seems to have a type of symmetry that should be forbidden under normal circumstances in regular crystals. Again, that was something I had guessed at it, but it still strikes me as a somewhat unusual and surprising Nobel Prize even now. So, as I said, it's good to look at these analyses to try and figure out what is it that the community thinks is important to them. And what is it that my work today would not be successful or would not get where it is had it not been for the people who came before me, and in particular these discoveries. So that's where I think is really useful and nice.
So Gautam, clearly when somebody is starting off, right, I mean when they're in doing their bachelor's or master's or even their PhD, a Nobel is a moonshot, right? I mean your percentage chances of winning are 10 to 0. But as you become more advanced in your career, and if you're a successful scientist who's, publishing great papers in great journals, getting cited well, getting other kinds of recognition from your peers and elsewhere, perhaps the chances of a Nobel tend to become a little higher, right? The probability goes from, 0 to, 0.1% or 0.01% or something. So do you think there's a time when scientists start shaping their science, hoping that they can land a Nobel? Have you seen that happen around you? And, we can have our value judgment on it separately. But in real terms, I feel like people might want to leave a mark and might want to do things that they think would win them a Nobel.
I'm not so sure.
Have you seen this happen?
Because I think as you sort of begin to do so, certainly when all of us are young and we all want to be scientists, we want to get the highest prize that there is in science. But as you begin to actually get into the practice of doing something, you realize, first of all, that the Nobel Prize is a moonshot in more ways than one. It's not just hard to get. It's just that you must be in a specific place in a particular time doing a specific thing that may later turn out to be important, but while you're doing it may not turn out to be the most significant thing that you think that you've done at some point. And it depends a whole lot on luck. And pretty much luck, I think, is a sort of foundational question. Which model system, if you're a biologist, you decide to study, what questions you like to ask, what impact those questions will, how many people are doing it and competing with you as well. It's no use in Nobel Prize sweepstakes, it's no use being second. You could have done a great job, but if you're second even by a few months or a year, then you will perpetually be second. So I think we all recalibrate what it is that we do. I don't particularly see sort of people having, usually the Nobel Prize is awarded for one thing. And by the time you reach the stage where you worry about it, you've already done that one thing. And then the question is the Nobel Prize Committee going to recognize you for that one thing that you did, or is it going to be lost in the whole spate of other discoveries that there are? And some things you can recognize immediately as having importance. For example, this whole field of super resolution microscopy, which has taken over a lot of microscopy techniques in biology. It's a very, very precise way of looking at a very, very small scale to see how biological systems, living cells function. That's one technique. This technique of cryo-electron microscopy, which again is sort of giving us unprecedented insights into the structure of biological molecules. All of these certainly are very important. And you can see that they're technological breakthroughs. You should never underestimate the importance of having a new technique. And often it's new techniques that drive huge areas, a huge new opening that really open up a field completely. And they can be completely pivotal. It's not really a discovery as a technique. And techniques are probably the best way to get a Nobel Prize. If you're in the sort of technique space, where you think about what can I do to make a difference? What new technique can I invent that makes things just faster, cleaner, clearer, better in terms of my measurements? Then I think you stand a chance. That's a sort of, it's a more general area.
Right. And this year's chemistry award for CRISPR-Cas9 is a great example of exactly that, right? Exactly. It's a technique. Yes. It has immense research applications. It also has potential therapeutic applications. And that's why they won the award.
That fits Nobel specifications perfectly. It has to have some value for mankind or usefulness to mankind.
The reason I even brought up this question is, so I dabbled in a bit of science. I also had an aspiration for a Nobel and, doing science at one point before I sort of switched tracks completely. And I'd come across someone who was working in nuclear magnetic resonance, right? This, again, very powerful technique, which can yield a lot of insights on biological molecules, how they're structured, how their dynamics are, and so on. And somebody who's working in that field, and again, these are anecdotes, but Kurt Wuthrich in 2002 shared the chemistry Nobel for his work on NMR and its application to biological systems. And I think the award was shared with two other scientists for doing work on mass spectrometry, another very, very important and useful technique. So the story is that after the NMR Nobel was won, the idea is that now there won't be another Nobel for NMR-related work in the foreseeable future. Maybe, 2 decades later when some other gigantic innovation happens. So this person I know, a very, very well-cited scientist, his last PhD student finished up soon after. and the person pivoted completely away from NMR, thinking that, this is not where I can find my next high impact research, if not a Nobel, right? So I wonder if, that kind of a thing happens when you're hoping, that there's luck at play, but if it doesn't pan out, then put your eggs in a different basket.
I would think that is rare. I mean, at least specifically for the reason for doing it for a claim of some sort. Most of us, by the time we reach that stage of life, we have a body of work behind us. We have, we're sort of known for doing certain types of things. And most of us, again, will proceed along those tracks. A very few examples I know of someone who's completely willing to shift track completely would be S. Chandrasekhar, who had this habit of every 10 years, he would move to a completely new field, work in it for 10 years, write the definitive textbook in that field, and then move again after that. I think he did that essentially to sort of maintain his freshness as a scientist and make sure that he was constantly thinking about new things. But I know of practically no one else who would be able to do that at that particular level, especially now. So I don't think...
But at the same time, people pursue parallel ideas, and then if one starts yielding more results, they might end up doing more of that, right? Like,
that's possible.
I mean, for example, even in your own career, you do a lot of theoretical physics, you do a lot of physics applications into biological systems, and at different points, they might give you different yields, right?
That's true. But I mean, I'm not sure that I would abandon one of them if I thought that it would lead me to more sort of prizes or acclaim or something. I think it would be more the scientific challenge of something. If I feel that there continues to remain a scientific challenge in a particular area, that's certainly a reason to pursue it. And as opposed to, I mean, we all do choose the problem that we work on for different reasons. There are some that, we're obsessed by when we were PhD students, and they stay with us for the rest of our lives. And we really think about them a lot. When we go to sleep at night, we think about them. Even though we're not actually working on them, they stay at the back of our heads. And there are things that we do just to sort of keep in practice, to work with students, to train people, etc., etc. So we maintain this sort of sheaf of different things that we do, changing our interests from one to the other, looking for a little bit of space to do something new in one. I think that's how most of us proceed. But it's relatively rare, I think, to sort of abandon a field because I don't think there's a prize in it anymore. That I mean, unless you're sort of really functioning at a level where these things make a difference to you.
Right. And, on the flip side, I heard an anecdote about Rudolf Mossbauer, right? And he's someone who won the Nobel for Mossbauer spectroscopy, named after him, which he discovered in 1957 when he was still in his 20s. He won the Nobel in 1961 when he was just 32, right? Phenomenal work. And apparently, so this is much later, I think in 90s, during an India visit, an acquaintance of mine asked him about, what's he doing now? Is he still working on things related to Mossbauer spectroscopy? And apparently he said, no, I abandoned that field decades ago because it's become way too competitive. When I did the Nobel winning work, I was, alone doing this. After that, it heated up too much. I couldn't manage, so I moved on. And that to me was fascinating.
I agree. So I have an anecdote that is like that. When the Nobel Prize winning physicist Pierre-Gilles de Gennes, French physicist, came back to France after doing a postdoc in the US, he sort of built up an area of work in superconductivity, working with French researchers, but then decided to pivot to a completely new field, which is the field of liquid crystals and soft matter physics. The reason he did that was that he said that, look, there are these big labs, Bell Labs in the US, big university labs, well-funded. We'd never be able to compete with them in this area. So let's choose an area where we don't have to worry about funding, where we don't need large amounts of money, we don't need very complicated equipment. We're not going to sort of, be in an endless competition with groups that are much better funded and have, many more people to work on this. Let's choose this area. Let's choose it deliberately because we think this is an area where we can actually make a difference that we would not be able to if we were just working on stuff that they were also working on. So that's a nice point that goes back to this question of how do you choose your battles in a sense. And it certainly probably does not pay unless you really have an idea that makes a difference to compete with groups that are much larger, much better funded, have just much more connections, networks than you have. And then it makes sense to pick the right battle there and say that, look, here is where the niche that no one is looking at. And this is the niche where I can make a difference. And maybe, of course, he got his Nobel Prize 20, 30 years later for work that really was initiated in that sort of spurt of effort with the French group in the early 70s.
Right. And I think there's this webcomic author, I think, who talked about how all research, especially every PhD, might be a tiny pimple on the gigantic balloon of of scientific knowledge. So it's about where you choose to make that little dent and what niche you choose to occupy. So, Gautam, thank you so much. And as a parting thought, we often get excited when an Indian origin scientist wins the Nobel. Venki Ramakrishnan was perhaps the most recent example. And, every so often you have this conversation that happens in India that, we should do X, Y, and Z such that in 10 years an Indian should win the Nobel. So, we talked about how G.N. Ramachandran is perhaps the one Indian who certainly did Nobel-worthy work and came closest to winning a Nobel for work done in India. But how do you see this problem? Because one, doing this kind of research and building these institutions takes decades, right? And two, do you think we are in a place right now where you have potential Nobel winners who are starting their careers?
Okay, I'm going to make myself a lot of enemies, I'm sure. At the moment, I don't sort of see anything that I would instantly say that here is a Nobel in the making. Here is someone, here is an idea, here is something whose importance will be known maybe 10 or 20 years later. I see lots of very nice work, extremely competent, high quality work from Indian scientists. But I don't see that sort of that little bit extra that I might think would extrapolate onto a Nobel in the future. Maybe even more than that, I'm not sure that is the direction that we should take as a question of science policy. Should we look at a one-shot thing like a Nobel as an index for how well we're doing in science, as a sort of mark of how we're regarded in the world? That's, as I said, Nobel is a chancy affair. There's a lot of luck that goes into it. And, as I said, many people who don't get it are equally qualified, or they, in some different way of looking at it, they would have been even more perhaps eligible for a Nobel than the person who actually got it. So I think we should spend our time more on improving the general quality of our scientific institution, broad basics, making people think more dangerously. So that's, again, let me be a little more specific about that. As I said, the really big changes in science usually come when a new technique is invented. And I gave you the examples of the super resolution microscopy techniques, a whole bunch of techniques around that. I gave you the example of the cryo-electron microscopy. Combinations of both hardware, software, a whole bunch of things had to come together for that to happen. I don't see, in a sense, that we are aiming for that, for being the sort of cradle of new techniques that can then be applied. I think that's a different way of looking at it. We are sort of looking at what are the successful examples that we can think about Indian science. Let's give them more money, let's push them, maybe they'll get a Nobel Prize. That may not be the way to do it. I think it has much more to do with how we train people to think creatively, train people to work with their hands, train people to be innovative in the sort of experiments that they do, to be fearless, to look at new things. There's one person I know, as it happens, a potential Nobel Prize winner, but I'm not going to embarrass him by revealing his name, said that you should always have space for these Friday night experiments where you do things that are not being done in the lab, but just it's sort of completely different and a little, at a tangent to what you're normally doing, just to sort of explore and see what might actually be happening. And I think that's important. We don't have enough of that. We don't have enough of that tendency to veer off from standard directions. Partially, that's just a system in which everybody...
A risk appetite, if you will, right?
A risk appetite. So how do we increase our risk appetite? And how do we make sure that is done? That, I think, is important to do, really.
And which might mean that some of the battles that Indian scientists have to fight daily, we should get them to a place where they don't have to fight those battles anymore, 100%. Right? I mean, if I'm not mistaken, say if you're an experimental scientist, even in a top institution in India, setting up a lab, you have to do the civil engineering work. You have to do the plan specs for how your lab should look. Yeah. You should figure out, even if you have money, you're spending time on things that otherwise in any other part of the world, in a comparable institution, you'd have people to do that for you, right? You'd have administrative and systemic support. And now you're this one person entrepreneur in science who is doing everything, right?
Exactly.
From fundraising to figuring out the AC, whether it works or not.
Does the AC work? Does the power come? Does it use the UPS on? Does my liquid nitrogen come? All of this are sort of day-to-day irritants that we have to function with. And if you remove that, there'd be a lot more space for people to be more experimental, more risk-taking with their science. And I think overall, we tend to be a sort of theory-heavy country. We encourage people. We sort of overvalue the importance of equations written on paper and the sort of the airy genius who dream stuff out of nothing. And we tend to devalue the working with one's hands, the actual experimental technique. I think if you want to look at Nobel Prizes, that's a very important component to sort of stress the importance of good experiments, stress the importance of being innovative in those particular areas.
Gautam, thank you so much for joining me on this wonderful conversation and, using the Nobel Prize as an excuse to sort of look at science and the practice of research, perhaps from this lens. And would you have any parting quote from a Nobel winner or somebody else which you think is cogent to our conversation today?
As it happens, I do, Pavan. So let me just read it out. This is a quote from Venki Ramakrishnan from his book, The Gene Machine. So let me just read it. I like it a lot. He said, "So I don't subscribe to the heroic narrative of science. Rather, some of us are fortunate enough to be the agents of important discoveries that would have been made anyway, sometimes not even that much later. But this cold, analytic view does not sit well with our emotional selves. We humans tend to personify everything we touch. We give names to theorems and theories, discoveries, laboratories, even pieces of apparatus. Science becomes a play with heroes and villains. So even if discoveries are inevitable, we recognize that it is individuals who make them happen, and we like to honor those who took that first leap into the unknown, to go just beyond what was thought to be possible. And when someone like Newton or Einstein sees much further than others, or Watson and Crick synthesize in one stroke the essential features of DNA that might have dribbled out in pieces, we tend to immortalize them." And this is a sort of quote, so this is Venki Ramakrishnan's quote, and it's a quote that I think is particularly germane, that even though we know that we are just agents of discoveries, other people would have done it sooner or later, we're just, in a sense, collating things that we're building up on work that other people have done. But it's a natural human tendency to personify this effort, to say that this is person X or person Y or Watson or Einstein or Crick were the people to whom all of this honor should accrue. And we recognize that through a Nobel Prize, which has been the subject of our discussion today. But it's important to realize the background. We always build on the work of others. That's crucial to what we do as scientists.
Gautam, thank you again for joining me. It was an absolute pleasure to have you on the Pragati Podcast.
Thank you so much, Owen. Pleasure to talk to you.
Thank you for staying with us till the end. If you have any questions or comments, do write in to podcast@thinkpragati.com. And hey, if you like the podcast and listen to us on iTunes or Apple Podcasts, please leave us a rating and a review. It'll mean a lot to us. The Pragati Podcast is available on the IVM Podcast app and pretty much every other podcast app and platform. We are there everywhere.
Hi, my name is Anupam Gupta. I'm B50 on Twitter. I am the host of Paisa Vaisa, a show that talks money. On my show, I speak to experts from every field of money and finance, from stock markets, equities, debt funds, credit cards, life insurance, every possible area of money and finance that you can think of. We even did an episode on cryptocurrency. I've got fantastic guests from mutual funds to personal finance experts everywhere. Robo-advisory, startups, just name it, we've got it. At Paisa Vaisa, we help you make smart decisions about money. You work hard for money. Now make your money work hard for you. New episodes out every Monday, and you can listen to my show on the IVM Podcast app or any other podcasting app that you have.
Entertainment is like food for the brain. It's a window to culture and a great way to understand the world around us. The internet has changed what it means to be an entertainer, creating new storytellers with millions of fans. It has spawned a new breed, the story-sellers, those behind the scenes creating the business for this ecosystem. They work with brands, platforms and channels who are keen to capitalize on an audience hungrier than ever for more stories. I'm Vineet Kanabar, and I have a ringside view to how stories are told and sold. On my show, I bring you creators, artists, executives and marketers for a freewheeling conversation around the business of entertainment. Tune in to Storytellers and Storysellers for personal stories, analysis and criticism every Thursdays as I talk to the brightest minds telling or selling great stories today.